Today's lesson is over angles and triangles, and the goal will be to classify triangles by angles and their sides. So, classifying triangles by angles, we have an acute triangle. It's a triangle that has three acute angles, and there's an example of one, but there could be other drawings as well. We have a right triangle. Easy to identify, it's a triangle that has one right angle. And if we have a right angle in a triangle, well, I guess it's important to know that all triangles have a total measure of 180 degrees. So if 90 degrees are taken up right here, then the other two angles combined are 90 degrees. So they're both going to be acute angles because we can't go, they're both less than 90. And finally, we have an obtuse triangle. This is a triangle that has one obtuse angle. So just by angle measures, we're going to classify these three triangles. You guys think you can do it? Go ahead and pause it, try on your own. Otherwise, stay with me. Number one, we can see we've got an acute angle here, an acute angle here, an acute angle here. Three acute angles, by definition, makes an acute triangle. I'm just going to short and abbreviate it by doing that. Number two, we have an acute angle here, and then an obtuse angle here. So by definition, that gives us an obtuse triangle. And the last one, when we see the right angle right here, we can stop. We know that makes a right triangle. Now, another way of doing this to classify triangles is to classify them by their sides. So we have what's called an equilateral triangle. This is a triangle that has all three sides that are equal in length. And notice the red tick marks. The fact that there's one per side tells us they're all the same measure. So equilateral triangle there. An isosceles triangle, it has at least two sides of equal length. Again, we can see the tick marks. Those two sides are the same. Equilateral, or isosceles. Finally, a scalene triangle. A triangle has no sides of equal length. So if there are no sides marked, and we're asked for the type it is, scalene. If we see something like this, okay, we have three different sets of ticks. That tells us they're different as well. So that's a scalene triangle. So by side lengths, we're going to identify the next three triangles. You guys want to try on your own? Go ahead. If not, stay with me. In the first one, we see that we've got two lengths that are the same, only two. So that is isosceles. Make sure I spelled that right. I did, okay. Next, we've got one with three different side lengths. Makes it scalene. And then the last one, they're all the same. Equilateral. Okay, that prefix equal, or it sounds like equal, kind of a giveaway there. All sides equal. Good little trick. Now, we're going to find unknown measures in triangles. So as a reminder, all triangles have a total degree measure of 180 degrees. So if we know two of the measures, we can find the third. Okay, different ways of doing it. I just know that we have 42. If we add that to 42 plus x, we ought to get a total of 180. Okay, 42 and 42 is 84. And one-step equation from there, subtract 84. X equals 96 degrees. So that is the measure right there, 96. Go ahead and try it on your own with this one. I'm going to go through the same format. If you guys want, you can probably do this a little bit differently. Maybe some of you can do it mentally. I'm going to write it out regardless. Let's get this out of the way. So the one step from here is all based off our knowledge that triangles have a total of 180 degrees. for the angle measures. So 52 is left over there. Okay, throw a little bit of algebra in here for you. Again, based on our knowledge that all triangles have a total measure of 180 degrees. So we take our three sides and we add them up. So 70 plus x, right? 70 and x, and add the 3x plus 10. Total of 180. Combine like terms on the left side. So 70 and 10 gives us 80. X and 3x is 4x. Now it's a two-step equation. Subtract 80 from both sides. And divide both sides by 4. .25 degrees is x. Okay, moving forward, we got one last thing to do. There's something in math called the triangle inequality theorem. Here's what it means. And we're going to have to know this, okay? This actually is on the notes page. This should have been taken off. So you should see a spot for this. It says that any side of a triangle is always shorter than the sum of the other two sides. So let's say it again. Any side of a triangle is always shorter than the sum of the other two sides. So here's how it looks. We've got a triangle, okay, with side lengths of 3, 5, and 7. So what we do, we pick any two sides, okay, and we add them up. So, for example, we did 5 plus 7, which we know equals 12. And the remaining side of 3 is less than 12. So that works out. Then we can pick two other sides, so 3 and 7, which equals 10. So the remaining side is 5. 5 is less than 10. That one checks out. Finally, we check the other one. Okay, we take 3 and 5. So put that in blue. We have 3 and the 5. We add those together. Gives us 8. The remaining side of 7 is less than 8. Since all three inequalities are true, these are legitimate measures for a triangle. Now we test this one. Okay, so start off with do 9 plus 5, which is 14. The remaining side of 3 is less than 14. That one checks out. We can test now, let's say 3 and 9. Okay. 3 plus 9 is 12. 5 is less than 12. Checks out. We've got to check all three. You guys see the answer already. We do 3 and 5, which is 8. 9 is actually greater than 8. Okay, so since one of these measures doesn't work out, these are not legitimate side lengths for a triangle. It's not going to work. So I'm saying on your own. You may want to watch one with me to see how it goes. You want to stop it and try it out, you can. But we're going to test all three possibilities for each triangle. So this first one, I'm going to go ahead and add 4 and 8. So 2 should be less than 4 plus 8. 2 is less than 12, so that one's good. Now I'm going to check, let's say 8 and 2. So 4 is less than 8 plus 2. 4 is less than 10. That checks out. And now I'm going to see if 8 is less than 4 plus 2. That is not a true statement. So this one, the answer is no for number 1. Let's try number 2, 5, 6, 7. So is 7 less than 5 plus 6? It sure is. Is 6 less than 5 plus 7? Yes, it is. And is 5 less than 6 plus 7? It sure is. So this one's a yes. Finally, this last one. Is 6 less than 8 plus 15? Yes. Is 8 less than 6 plus 15? Yes. Is 15 less than 6 plus 8? No, it isn't. This becomes 14. So that would be a no. So that's not a possibility to be a triangle. This concludes your lesson over triangles and angles.